partecipazione dei presentatori non italiani, quindi continuiamo in lingua inglese. So, the next talk of Dr. Massimiliano Dispenza, Head of Quantum Optics Advanced Material Lab of Leonardo Company. The title of his presentation is Quantum Technologies for Aerospace, Defense and Security in Leonardo. Please, 15 minutes together with questions.
Will be more standard, and so very quickly, the idea is of the talk is to give you an overview of what's going on. How in Leonardo, what's the strategy and governance we adopted in interconnecting the quantum activity with the quantum activity with the rest of the division, and a few examples, the divisions of the business division and the rest of Leonardo, and then what's going on in terms of technical activity. Okay, this one. Okay. Okay, what's Leonardo, just quickly, is a player in aerospace and security. So helicopter, defense, electronics, security, space, aeronautics. So this is the kind of business to which is our R&D activity on quantum is supposed to be interconnected. So here where we are in the Leonardo Innovation Hubs, that is within the Strategy Innovation Group in the headquarters. And here, what's the mission? The mission is to target the R&T, which is the low TRL activity, which means the part of the research activity and the R&D activity that is mainly cut off anytime there is a need of a spending cut and saving. So this is a kind of activity you cannot keep in the divisions, and this is the kind of activity that was decided now a few years ago to be centralized in centralized labs, and Leonardo Quantum Labs is part of it. Okay, I'm in charge of a larger cluster of labs. This is quantum electronics and advanced materials. And I put this here just to give you an idea of the footprint, but also an idea of how they can be interconnected. Competencies in electronics can be leveraged as well as in materials in order to so that they can be used in quantum activity. The quantum lab is in Rome. Also, the HPC, that is a centralized asset, is also exploited by the labs and also from the quantum labs. So, what happens when you try to drop quantum activity and into an aerospace, so a very large player, a big company, which is already rooted in so many markets in aerospace and defense, and already has a lot of divisions with different businesses. The first thing is that you need to have a matchmaking between the centralized labs, quantum lab researchers, and the needs from the division. Then, and with a specified point of contact. This is crucial in order to avoid that on one side, researchers just go in a free way with no guidelines and no directions, and on the other hand, that the division has no responses and the funding and the investment on the centralized labs has no return on the actual return on the business. Then after this matchmaking, this is continuous activity. We have a selection and also a discard of research streams. Then internal investment. Then after that, we definitely decide that we still keep a strong activity in cooperative and national and international project and in a big networking. Okay, this is the first part. matchmaking means and meant at the very beginning the discovery that there is a very transversal product portfolio in the many divisions that can make sustainable the quantum technology activity on all of the three pillars, because all of the three pillars have potentially an application on all of this kind of types of business. Then that's the kind of organization in terms of the area of in which the quantum technology is activity and research activity is carried on. So communication and network, imaging, sensing, computing. I'm not going to talk about computing. A colleague of mine that is talking about that later in the afternoon. Computing. We are not developing and implementing actual hardware computer in Leonardo. On the other hand, we are doing experimental activity on all of the other three research units. Then, okay, this is this is an idea of what's a project portfolio and collaboration. That means what is the kind of networking we decided and we implemented in terms of European project, European Commission project, space agency projects, and national project, both in communication, computing, imaging, and sensing, in the defense and in civilian application, quantum flagship, or the European Defense Fund. You see many big players in the industry, as well as in the university, from Fraunhofer, Max Planck, or also other companies, and the Italian CNR, and the Meteorology Institute, and so on. So, okay, let's just a quick overview of what's going on in the first area, quantum communication and networks. So, as we'll see, the general idea is that we start at the same time with low TRL activity and higher TRL. You see, in this case, on quantum communication, we are experimental activity and development of more standard activity, as Simone anticipated, as QKD, QRNG, or post-quantum crypto. And the main target of this left side part is not to develop specific component, which is that's because, in fact, Leonardo is not a component developer, but a system integrator. The idea is to use them as building block in order to develop full stack network from the physical layer to key management system to the service. On the other hand, in the pipeline, at a lower level, we already entered into the activity of quantum entanglement distribution, both at the first time as a modeling activity and a software on the software side of the activity, but also having experimental activity that are also connected to other internal capability, in particular with the cold atoms activity that I will show you in quantum sensing for navigation. And so that's okay, a general overview. That's the kind of outcomes that we already achieved. We have QKD devices already developed that are now in technology transfer towards a specific business division, that is a cyber business division. Then we have terminal that are able to feed this kind of quantum, the quantum state for key distribution, both in free space and in fiber. Then there is a parallel activity on post-quantum crypto. And then we implemented by this several networks. One example was last year in Naples and Campania, the implementation of taking part to the network of which one node was in Leonardo Pomigliano and the other in Federico II and CNR. Now we are close to have running a Rome network, which includes all the Leonardo and Telespazio sites in Rome, and that is also interconnected to the that is also connected to the Italian quantum backbone. Okay, this is international activity, and this is how the ideas on QKD is implemented with a participation to this kind of quantum communication infrastructure in the space segment, terrestrial segment, in the Italian deployment. I don't go deeper because I feel like you are familiar with this. Then this is what you are doing in the beyond QKD. So that's what I was anticipating. The entanglement swapping with the target of secure multi-cross domain networks, both in civilian and defense, with all of the listed potential applications. So distributed computing, distributed sensing, blind computing. Okay, so second area is quantum imaging. First, higher level single photon detection application for non-line of sight imaging on 3D LiDAR through fogs, smokes. On the other hand, use of the entanglement, lower TRL. So that any time something exits from the higher level of the pipeline because it goes to the business division, from the lower level, there is something already boiling in the pot. Okay, that's some result again. On the top part, you see no line of sight, seeing behind the obstacle approach. So when there is any kind of obstacle wall, a technique using single photon detector and its capability to tag any photon with a precisely picosecond time of flight can be used in order to send photons through any relay wall or floor or flat or even ceiling or whatever in the hidden area. And that's the result. You see how we can reconstruct in this area, which is totally not accessible, that there is a person that is moving in the right way, that is moving his legs up and down, and then is opening his legs. And okay, that's totally real time. And that's a raw data. And then there is a potential improvement by using AI technique or something like that. So second, use of single photon of the same system. This is a single system with dual function, is sending through fogs, through camouflage, the same single photon and gating them in order to overcome the fog, the smoke, or whatever. As to the lower TRL, okay, this is a more exotic use of the entanglement. Okay, I go very quickly, but the idea is to have a system with entanglement generation in two sites, so that the total, effect and the token event is the superposition on two kinds of event. One in which the generation is done in the first crystal. The other one is done in the second crystal. As you see, we have infrared photon going to the detector, to the target, and visible photon not interfering with the target. At the very end, the fact that we have entanglement between the two allows just totally discarding the only photon that interacted with the target, which is the red one, the infrared, and using the visible to extract the information. Okay, and okay, I should have a video here that shows that if I just put in front of the invisible photon an object and also I'm able to make an image with I'm able to make the image with the object, now also a smaller object. by using the visible camera. What you see is seen by the visible camera, even though the only photon that sees the object is the invisible photon. So this is crucial. It's interesting because you could see and illuminate object even with kind of light for which no one has ever invented any detector, and still at the same time use a visible camera as a smartphone camera to look at the image of that detector. This is, as you can imagine, very important application even in security, in defense, because infrared light is much more penetrating and cannot be detected. And on the other hand, you can use visible cameras to see the image. Then, okay, third area, quantum PNT, sensing for PNT. So quantum clocks on the left, and using and quantum accelerometers, using this based on miniaturized and cold atoms technologies. This is the kind of technology, cold atoms, make the atoms frozen, use them for accelerometers in the atomic interferometers and as atomic clocks. And then there is also ongoing an activity on a fiber optic gyro that is also using rubidium, the same matter platform, in the interferometers of the Sagnac interferometers. All of this to build up a quantum-based GNSS independent inertial navigation system. Okay, I skipped the computing. This is a general picture how to it is possible, feasible, potentially to integrate all of this type on a future systems for security, defense, and aerospace.
Okay, thank you very much.